By the late 1980s, the computing landscape was expanding into a fractured network of proprietary systems. For developers, this growth created a significant technical bottleneck. Building a single application meant writing completely different instructions for every target machine, multiplying the cost and time required for every new release. Microsoft's rise provided a dominant standard for the PC market, but its ecosystem remained isolated. Programs built for Windows were locked into that specific environment. Apple's Macintosh offered a distinct, competing architecture. This divide forced software creators to choose which hardware to support, effectively partitioning the digital world. This fragmentation capped the potential of the industry. Software was expensive to produce and difficult to scale, as every new piece of hardware required a ground-up engineering effort. At Sun Microsystems, a team of engineers began looking past the desktop. They envisioned a future where a vast variety of devices would need to communicate without a single company owning the underlying operating system. James Gosling led Project Oak, an initiative to create a language designed for small, heterogeneous devices, electronics that didn't share the same internal components. Visionaries like Bill Joy saw that the internet would soon demand a portable language to bridge hardware gaps, allowing code to travel across the network regardless of the recipient's processor. To achieve this, they moved away from hardware-specific code, designing a universal blueprint that could run on any machine with the right translator. Sun publicly announced Java on May 2, 1995. They marketed it with a clear, ambitious directive: write once, run anywhere. Standard programming languages compiled into machine code, binary instructions shattered into specific formats for one type of CPU. Java instead compiles into universal bytecode. Translation is handled by the Java Virtual Machine, or JVM, converting that universal bytecode into specific local hardware instructions. This allowed a developer to write a program once and deploy it to dozens of different operating systems simultaneously, removing the friction of cross-platform porting. By isolating software from hardware, Java shifted the center of gravity in the tech industry, allowing developers to focus on logic rather than machine-level compatibility. Java's first public success came through applets, bringing the first wave of interactive animations and tools to the previously static pages of the early web. While these applets defined the user experience for a time, they eventually succumbed to security flaws within web browsers, leading to their gradual phase-out. This decline in the browser didn't hinder the language's growth. Instead, Java moved into the backend, becoming the primary engine for heavy-duty corporate servers and database management. It transitioned from a visible web tool to a reliable server-side standard, quietly managing the high-volume data of the global economy. Today, Java functions as a pervasive layer of the world's digital infrastructure, even if it is rarely visible to the average user. 90% of Fortune 500 companies rely on it to maintain their core systems, using its stability to process trillions of dollars in global finance. It provided the architectural stability required for companies like Netflix, eBay, and Twitter to manage the massive influx of traffic during their early periods of rapid growth. That same focus on portability led to its adoption as the primary language for the Android operating system, extending its reach to billions of mobile devices globally. Java has evolved into a high-density utility. It operates within systems that underpin the logistics, banking, and communication sectors worldwide. To understand why a language from 1995 remains relevant, we have to look at how it manages the passage of time. This longevity is driven by temporal portability, a commitment to extreme backwards compatibility that is rare in the software world. Modern versions, such as Java 21, continue to add sophisticated features like pattern matching and advanced records to meet the needs of contemporary developers. Despite these upgrades, code compiled on a JVM in 1995 can still run flawlessly on a modern Java 21 environment. Java's legacy was more than just solving the fragmentation of the 90s. It was the creation of a reliable standard that allows decades of software investment to remain functional while the hardware beneath it continues to change.